Um, Today we're going to look at Unit 7, and this is the time series analysis chapter or unit. Okay, so this is a very short, relatively simple chapter that we will look at. Now, the first thing we need to know is what is the difference between cross-sectional data and time series data. Now, with cross-sectional data, this is what we've been talking about pretty much in the first 6 chapters. Now, cross-sectional data, this is gathered from a sample. Sample survey at a particular time or at one point in time. Okay, so that is what cross-sectional data is. Now, time series, in contrast to that, time series data, this is data that is gathered over a period of time. So let's say you're interested in the age of NAS students. Instead of just collecting a sample today and then telling me that the average age of NAS students is this much, what you will do is maybe you started 5 years ago, and every year in October, you calculate the average age of students. So that collection of data over a period of time is what we would call time series data. So this is the collection of data values or measurements at equal time intervals. Okay, so this one just at one point in time, like you collected today, but then time series, you collect it maybe every October for the next 10 years or so, or every month on the 15th, for example. So that would be time series data. Okay. Now, the reason we look at time series data is we want to see, is there a pattern that we can discern? And then if we see that there is a pattern, we want to be able to say, can we say something about what it's likely to be in the future? So we want to forecast. So a trend or a pattern So you look at the data and then you might see there is a trend or a pattern. This is observed from real data. And is used to forecast future events. And thus help us to plan. Okay, so for example, if we're looking at number of students enrolled at NUST, so let's say we've been collecting the data over the past 10 years and can see there is an upward trend. That means it is constantly going up. So we look at our buildings and say, okay, 10 years from now, how many students are we likely to have? Will the buildings that we have be able to accommodate all those students? So you can forecast 10 years from now, and then using the data that you've collected in the past, and then that will help you to determine whether the infrastructure you have now will be sufficient, or you already need to plan and say, okay, in 10 years from now, we'll need 2 extra buildings. So let's start budgeting for that. Let's start planning for that. So that is why we collect these time series data. So in short, time series is what we call a forecasting tool. Okay, so we want to forecast and say this is probably what we're likely to see in the future, and then we can plan for it. Now, there are some components that affect your time series data. So we have components of your time series. Number one, we have the circular component. Okay, so with you guys, we're not going to go into too much detail of what each of these components are. Mostly, we just want you to know what the components are. Now, the circular component, this is just the overall pattern. Is the data going up or is it going down? So if we look at maybe the number of students enrolled at NUST, what is the overall trend? Is it going up or is it going down? So this one is the overall trend. So this is, you can see this is the overall pattern of increase or decrease. So you're saying something about the data. So if I plot the points, let's say these are students enrolled at NUST every year. Okay, so let's say I plotted them that. Okay, so let's say this was the number of students enrolled over the years. Now you can see that even though at some points there is a decrease, overall the data is going up. So here you would say that there is an upward trend, that the number of students is increasing every year. Okay, so that is our first component, the circular component. Then number two, okay, so let me just give some examples of this. We can have the decline of a currency against another. So you can plot this over a couple of years. You'll see that against the US dollar, the rand has continued to weaken or something like that. So if you look at it for 20 years, there has been a constant decline. Okay, so that's just an example, not necessarily that that is the case with the rand and the US dollar. Okay, so another example would be the price of daily commodities. So this is, look at the price of daily commodities. So for example, if you plotted the price of bread over the years, you will see that it has been pretty much an uphill climb. So that would be an example of a circular component. And then we ask ourselves, what are some of the things that affect this? Urbanization, civilization, those are all things that contribute to whether something increases or decreases. But again, what we actually want from you guys is to just know what the components are, not necessarily to go into too much detail. So you need to know these are my time series and these are the components of the time series. The second one is the cyclical component. Now, the cyclical component, this one is long-term wave-like patterns. Okay, so if you look at your time series, maybe if you plot your data, say there's one here, then that. So you're plotting your data. And you continue plotting. You notice that it at some point it goes up, then it goes down, it dips, then after some time again it'll go up again, then it'll dip, and then it continues in that manner. So this one you observe it over a long period of time. So This may be something like business cycles or economic cycles. So you can see that sometimes the economy is doing very well, so things are good. Then after a while, it goes down, down, down. Then again, it builds up. Now, with this one here, these patterns, they're not at regular interval. They're not necessarily at regular interval. That if you measure the first cycle, if you measure the distance there, for the first time, it may be 2 years. And then for the next one, if you measure until you get from one recession to the other, if you measure it, this one might be 5 years. So they're not necessarily at equal lengths or at equal intervals, but you can see when you look at the data over maybe like 30 years, you can see, okay, went up, came down, went up, came down, and so on. So there is like a wave, there is a wave-like pattern that you can observe. And that is why we say this is a long term, sometimes medium, but it is something that you generally observe over a long period of time. Okay, and then we have our seasonal or seasonality component. Now, seasonality is slightly similar to the cyclic in that there are waves or there are patterns, but this one is short term and repetitive patterns. Okay, so this one with cyclical, we do have patterns, but they're not at regular intervals. But with seasonality, they are more regular. So you might notice it's short term. So you might say every Wednesday there is an uphill, and then every Sunday downhill. Then the next Wednesday again uphill, next Sunday downhill. So they are more regular and they are over a short period of time. So these ones, most of the time, you can observe them in a period that is like a less than a year. So there might be a weekly a daily cycle, monthly cycle. So with daily, you might notice that every hour, so around 12 o'clock, you can see that it goes up. And then maybe around 3 o'clock, it's down again. Okay, so these are short-term and repetitive patterns. So examples of this. So with the cyclic examples, we have business cycles or economic cycles. So how the economy does. And then with the seasonality, we have fishing seasons, so fishing, hunting seasons. We have demand for restaurants, maybe. Hotels, maybe. So you might see that in December, there is a high demand. Let's say at the coast, there's a high demand for hotels, and then maybe February, the demand isn't that much. So if you plot that even over the year, you can see that there is a pattern. Every December, there's a spike. February, maybe there isn't such a spike. And then April, May, when we have the Easter holidays, then again, there's another spike. And then around other holidays, whenever we have maybe long weekends, there is a spike. Okay, so that is the seasonality. So cyclical, long-term, wave-like patterns, the waves, there isn't really they are not really the same in terms of length, but you can see that there is a pattern. But seasonality, these are short term. They are also wave-like patterns or repetitive patterns, but you can almost predict them. They can say every 2 days or every 3 hours or something like that. So these ones, short-term repetitive, long-term kind of repetitive, but the cycles, they are not necessarily the same length. And then the fourth one, this is what we call the irregular or random. So sometimes it is called the random component. Now, this one, just like the name says, it's completely random. You cannot predict it. It happens when it happens. And That's how it is. So we have, these are short term, no pattern, and they are unpredictable. Okay, so for example, you can have crime, you can have a strike, example that the strike will just happen when it happens, a flood will just happen, the pandemic that happened, for example, let's say you were looking at mask sales. You're in the field of selling masks. Before the pandemic, you might see that your sales were maybe level, and then all of a sudden you see that there was a great spike in the number of masks that were being bought. So somebody who didn't know about the pandemic would say, what is happening? How come the mask sales just went up? And that was because of the pandemic. It just happened. It was random. It's not something that you could have predicted. So those are examples of the irregular components. So questions in the test or exam, when it says, when it wants to ask something about this time series, question will just say state the components. So you just need to know them. The first one is the circular, then we have the cyclical, the seasonality, and the irregular. We don't usually ask you to go into too much detail explaining them, but you should know something so that you can say something about each of them. But the most important part is to know what the names of the components are. So circular, cyclical, seasonality, and the irregular component. Okay, then what we want to do is analyzing the time series data. Okay, so we have data here and we want to analyze it. Now, there are two ways that we do it. The first one, or that we will do it, is what we call the moving average. And the second way, this is the method of least squares. Now, with the method of least squares, there are two ways that are mainly used. We will focus on the first one, which is sequential coding. And the other one is the zero-sum method. Okay, so we will focus on this method and also look at this one over here. So this method of least squares is also known as the regression analysis. Okay, so we'll be analyzing our time series data. With this moving average, usually we look at the 3-point or the 5-point moving average. So that means we look at an odd number moving average, but it is possible to also work out the moving average with an even number. So when you do it with an even number, there'll be an extra step that you do so that you have centered moving average, but with the odd number point moving average, it is pretty straightforward. And when we do some examples, you will see what I mean. Okay, so here's an example that you could get in the test. For example, it says you're given sales data for the Amanyala company. Produce a line graph of the quarterly sales data for the Amanyala company in thousands of Namibian dollars. Visually establish whether any pattern occurs over time. So here, what it means is just saying, are the sales going up or are the sales going down? So first thing is you need to make sure you read the table correctly. So you can see we have the years over here. So these are the years that way. And then these are the quarters going that way. So when you're plotting the data, you need to go down like this, and then that way, down like that from the top down, and then from the top down, and so on, because of how the years go. So you have 1987 quarter one, quarter two, quarter three, and so on. Then 1988 first quarter, second, third, fourth. 1989 first quarter, second, third, fourth, and so on. So you cannot read it like that, because that's not how a year or time works. First, 1987, you have to go through all the quarters of 1987 and so on. Okay, so usually on the x-axis, we will plot the time, and then on the y-axis, we will plot these values. So remember, these are in thousands. So this is, for example, 54,000, that is 58,000, and so on. Okay, so I'll show you how to do it. Okay, so you won't necessarily have to use graph paper. I don't think in the test or exam you'll be given graph paper. So you will just do it on your lined paper that you have in the test. Okay, so you just need to make sure that the way you do it is a good representation of this data in terms of your scale. Okay, so we said on the x-axis here, we are going to put our time, and our time is in quarters. So I have 16 of these. I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I don't have enough. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So these first quarters, so these are 1987, and then these ones 1988, and then 1989, and so on. Okay, so I'll only plot what I can, just so you get the method, you understand what it is we are doing. So I could even have started the one from here. Okay, now if I look at my values over here, the lowest one is 49, and the largest is, what is it, 99. Okay, so I need to maybe start here, counting in 40s. It's 50, 60, 70, 80, 90, and 100. Okay, so here's just to show that it is broken, but not really that important. So now we start plotting our first quarter, so 1987, and if you like, let's see, yeah, let's go ahead and plot them. So 1987, the first quarter, we got 54, so this is 24. We just plot the point there. Then in our second quarter, we have 58. So this is 58 over here. Then our third quarter, we got 94. And then our fourth quarter, we got 70,000. Okay, so also important that you label your axis, but that you can do even after you've plotted the points. So this is the quarterly sales. In thousands of dollars. Okay, so the fifth quarter, which is 1988 first quarter, is 55. So we have 50s here, 2/4, so it's halfway there. Then 61. Then 70. Sorry, seventh quarter, we have 87. 80, 2, 4, 6, there. Then The 8th quarter, we have 66. 6246. Then we have the 9th quarter, which is this one here, 49. Then 10th, which is 55. And then 11th, we have 95. Then in the 12th, we have 74. This is 72.4. Okay. Right, and then you would continue the same way with these ones. Now with these points that I've plotted, you just connect them with a ruler. So you take your ruler and connect them. So I don't have a ruler here, but I'll do my best to connect them. And then actually use the ruler I have here. Okay, so if you connect them, this is what you would then see. So of course you need to go further on. Here, instead of just going 1, 2, 3, 4, 5, and so on, you could also call them quarter 1, Q1, Q2, Q3, Q4, then Q1, Q2, Q3, and so on. I think that might even be a better way to represent it. So let's do that. So this is, call them Q1, Q2, Q3, Q4, and Q1, Q2, Q3, Q4, Q1, Q2, Q3, Q4, and just note that this is 1988. This is 1989, and you need another one for 1990. Excuse me. Okay, so if you've done it correctly, this is what it will look like. So this is one that you could draw even on your paper, which is not necessarily graph paper, because in the test you won't be given graph paper. So this shows all the quarters. This is 1987. So this one is here. Then we have 1988, 1989, and 1990. Okay, so now the second part of the question says, say something. Visually establish whether any pattern occurs over time. So is there a pattern that you can see? So what we notice is there is like a cyclical type of pattern here, or it goes up, then at some point it comes down, it goes up, then some point again it goes up, so it goes up, and then some point it goes down. Now we'll notice that every third quarter, so here, this is our third quarter, is the highest. Then at this point, the highest point here again is in the third quarter. The highest point here again is the third quarter, and then the highest point is the third quarters. So we have somewhat of a regular pattern. Okay, so we have fairly regular pattern with the highest sales in the third quarter. Okay, so that's the first thing that we notice. Now let's look at our lowest point. The lowest point here is in the first quarter. This is in the first quarter. This one here is also in the first quarter, and that one is in the first quarter. And then with the lowest sales, excuse me, lowest sales in the first quarter. Okay, so that is a pattern that we can clearly see. Okay, and if we look at our sales, our highest values, though it's not that much, our highest values are increasing with each year. So in 1987, it was here, then there was a decline in the highest sales value. Then after that, it has steadily gone up. So there is a small but steady upward rise. Of the sales. Okay, so that is something that we can notice. So that is just you looking at the graph and then you say something about it. Do you notice that the highest point occurs in a certain quarter? Do you notice that the lowest point occurs in a certain quarter? And then if you compare the highest values or even the lowest values, what can you say about them? The lowest values here, there was slight decline, but after that, they have been going up. Okay, so if your lowest value is going up, that means that the amount of sales that you are getting is increasing. Okay, so now what we want to do with this data is to work out what we call the moving average. Now, the moving average is slightly different from the average itself in that the average takes every single point into account, and then you add them together and then you divide by the number that you have. Now, the problem with that is you may have extreme values in your data, and those extreme values tend to affect your average. Now, when we're taking, let's say, a 3-point, a 5-point, even the 4-point average, what happens is those outliers, they don't have as much of an effect on your overall data as when you're just working out the average. Now, the way to work out the moving point average is really simple. So let's see how we would do that. This. Okay. Right, so this is our data and we want to work out the 3-point moving average. Now, when working out the 3-point moving average, what you're going to do is draw a table. So here we will have our quarters. I have quarter 1, quarter 2, 3. So that's 6. Sorry, quarter 1. So this is 1987. And then this is 1988. 1. This is 1989. This is 1990. Okay, so we are going to draw a table that looks that, and then in our next column, we write the sales. So this is the period or the time periods that we're looking at. Right down. This is our sales, which are in thousands of dollars. And then this, the next column, we will have our 3-point moving average. Okay, so we write down the sales. We have 54, 58, 94, 70. I think I need to make this a little bit smaller so we can see everything all at once. Okay, then 55, 61, 87, 66, then 49, 55, 95, and 74, 60, 64, 99, and 80. Okay, so we want to, this is question 3, calculate the 3-point moving averages. Okay, so the way this works is pretty simple. All you do is you are going to start from the top, and then you take 3 data values at a time, add them together, and divide by 3. So you take these first 3 together, then you will say 54 plus 58 plus 94. Do that on your calculator. This gives 206, and then you'll say 206 divided by 3. This is equal to 68.67. Now the 68.67, you write it at the second value. So this one is halfway between the 2 points above. So on top, you don't write anything. And then over here, you write 68.67. So it's exactly halfway between those 2 points. So if you're looking at the 5-point average, moving average, then you would write it at 0.3, because 0.3, there's 2 above and there's 2 below. And then you continue in the same manner. You look at the next 3 points. So you'll say 58 plus 94 plus 70. This gives me 222, and then 222 divided by 3, this is 74. So it goes over here because 94 is the middle point of these 3 points. So we just say 58 plus 94 plus 70. That gives you 222, and then 222 divided by 2 is 74, and it goes over here. Then you'd continue again. You take these 3 points, 94 plus 70 plus 55. This is 219, and then 219 divided by 3. This is 73. Okay, and then you would proceed until you get all the moving point averages. So let's do the next one. We have 70 plus 55 plus 61. This is 186, and 186 divided by 3, this is 62. And our next one, 55 plus 61 plus 87, 203. 203 divided by 3, this is 67.67. Okay, so these are the values that you would then get if you completed the table. Now, what you would notice if you were to plot these 3-point moving averages is that your graph would be smoother. There wouldn't be there wouldn't be too much of a difference between your highest values and your lowest value. So what the moving average actually does, it smooths out your data. So you don't have too much of a distance between high points and low points. Okay, so let's just plot these points and then see what we would get. So we're going to plot the 3-point moving average values. So the first one is at Q2 and it is 68.67. So 68, so somewhere there. And then we have 74 for the third quarter. Then we have 73, then 62, then 67.67. That's right here. And then 71.33. Then 67.33. Then we have 56. Then we have 56.67. So that's 50. So right here. Then 66.3. There. And 74.67. Over here. And then 74.7. Then the quarter here, the fourth quarter, we have 76.33. So this is 70 somewhere here. Then again, you would connect these points with a ruler. So you obviously do this with the ruler and it will look much nicer like that. So this is the 3-point moving average. And you notice there aren't that many spikes and troughs, that the difference between the high value and the low value is much um, less with the 3-point moving average. So you can see here I have high value and this one a low value, and the distance between them isn't that big. So what this moving average actually does is it smooths out our data. So before, lots of spikes up and down like that, but when you take the 3-point moving average, our data is much smoother. Okay, so that's one reason why we do this moving average. Okay, so let's see another example. And this one is straight from the notes. Okay, we want to calculate the 3-period and the 5-period moving averages for the 1990 monthly sales data in the table. So we're given the sales values here. We have the sales from January to December. So these are in thousands of dollars. So this is 7,000, 3,000, 5,000, and so on. So we can just represent them as 7,359 and so on. Okay, so now we want to work out the 3 and the 5 point or 3 and 5 period moving averages. The way we do it is exactly the same. So say here we have the period right in black. So we have a period. So we have January, February, March, April, Okay, so to work out our 3-point moving average, this one very simple. We know how to do it. We say you just take these 3 values, the first 3 together. So we'll say 7 plus 3 plus 5, that is 15, and then 15 divided by 3, that is 5. Okay, so the 5 will go over here in the middle value. So we have 3 months. The middle is the second one. So that's February. So the 5 will go at February. And then to get the next one, we do the same thing. We say 3 plus 5 plus 9 is 17. And then 17 divided by 3, this is 5.67. So this is 5.67. Then the next one, we'll say 5 plus 9 plus 7 is 21. 21 divided by 3, this is 7. Our next point, we have 9 plus 7 plus 9. This is 25 divided by 3. This is 8.33. Then the next one, we have 7 plus 9 plus 12. This is 28. 28 divided by 3. This is 9.33. Then continue in that manner. 9 plus 12 plus 4 is 25 divided by 3. This is 8.33. Then next we have 12 plus 4 plus 10. This is 26. 26 divided by 3. This is 8.67. And then next one will be 4 plus 10 plus 13. This is 27 divided by 3 is 9. And then we have 10 plus 13 plus 9. This is 32. 32 divided by 3, sorry. This is 10.67. And then 13 plus 9 plus 10. This is 32 divided by 3. This is 10.67. And then we stop there because if I take 9 and 10, I don't have another value here to add. So I don't work out the first and the second. So these are my 3-period moving averages. Okay, then I can also work out my 5-period moving average. I have my 5 period moving average. Okay, so this time, instead of taking 3 values at once, I'm going to take 5 values and add them together, and then I will divide by 5. Okay, so it's the same thing, except instead of taking or reading 3 values, I'm now reading 5 values. So this is 1, 2, 3, 4, 5. So I read these 5 values, and I'm going to put it over here at the middle value. So if I have 5 months, the middle month is March. So I'm going to start putting my value over here. So there's nothing at the first, nothing at the second, and my first value is going to go here. So I'm going to say 7 plus 3 plus 5 plus 9 plus 7. This is 31. And then I say 31 divided by 5. Thirty-one divided by 5 is 6.2. This is 6.2. And then I move on to the next one. I have 3 plus 5 plus 9 plus 7 plus 9. So we have 3 plus 5 plus 9 plus 7 plus 9. This gives me 33. 33 divided by 5 is 6.6. Then you move on to the next one. I have 5 plus 9 plus 7 plus 9 plus 12. This is 42 divided by 5. This is 8.4. Then 9 plus 7 plus 9 plus 12 plus 4. This is 41 divided by 5. This is 8.2. Then we have 7 plus 9 plus 12 plus 4 plus 10. This is 40 divided by 5. This is 8. Then 9 plus 12 plus 4 plus 10 plus 13. This is 48 divided by 5, 9.6. Here we have 12 plus 4 plus 10 plus 13 plus 9. This is 48 divided by 5. This is 9.6 again. Let's see. Okay, 9.6 again. So just check that you add the values correctly. And then I have 4 plus 10 plus 13 plus 9 plus 10. This is 46 divided by 5. This is 9.2. Okay, so that is your 5-point moving average. And here, of course, there's nothing because if I start at 10, I won't have 5 values. If I start at 13, I won't have 5 values, so we stop over there. So that is how we calculate moving averages. Okay, just a correction. I think this one here is supposed to be 8.4, not 8. Okay, because we are adding 7 plus 9 plus 12 plus 4 plus 10, which is 42, and then divide by 5, it should be 8.4. Okay, so just correct this value here. But the way that we actually work it out is the same. You're taking 3 values or 4 values or 5 values, depending on the period that you are given. Now, sometimes you're asked to find the moving period of an even number. And now the way that we work that out is not that different, except we have to do something extra. Okay, so let's say we wanted to work out the 4-point moving average of these values. So what we would do is, because with 4 values, there'll be 2 above and 2 below. You don't have a middle point. So I'll just show you how we would do that one. Okay, now with the 4-point moving average, the way we would do it is we'd still come up with our table like this, except that we would have an extra space between each of the months. So we would write it like this. We have period here and January, then I'd leave a space for February, then March, April, May, June, July. Okay, we need to make this smaller. Here we would have December. So this is how we would do it. Then we would put our sales amount as we did before. So for January, we had 7. So this was 7. This was 3. This was 5. Then 9, 7, 12, 4, 10. Did I skip one? I think I may have skipped one. Okay, let's do 7, 3, 5, 9, 7. Should be 9. 12. 10, 13, 9, and 10. Okay, so we would work out the moving sales average as we did previously, except this is a 4-point moving average. So we would take 4 points at a time, and then we would write the point between them. So that's why we left the space here so that we could write it over there. So we'd say 7 plus 3 plus 5 plus 9. This is 24 divided by 4. This is 6. So the 6 will come over here. Then we do the next 3. We say 3 plus 5 plus 9 plus 7. This is 24 again. And then we divide this by 4. This is 6. Is there. And then we have 5 plus 9 plus 7 plus 9 This is 30 divided by 4. We get 7.5. That goes here. And then we would continue in this manner. Okay, so these are the values that we would then get as our 4-point moving average. So remember, you're just taking 4 at a time, and then this value here goes between the top 2 and the bottom 2. All right, now remember, the reason why we do this is so that we can plot it on our time series chart. But if I wanted to plot this one, plotting this is easy because I know at January I'll put 7, February I'll put 3, and so on. But now the question is, where would I put the 6? It comes somewhere between February and January. Now, what we do is we call it centering. So we're going to take these two values, 2 at a time, 6 plus 6, we add them together and then divide by 2, and then that value will go under March. Then we'll say 6 plus 7.5, add them together, divide by 2, and then that one will go under April. And then that is going to help us when we need to plot them on the graph. So this is still the 4-point moving average, but this is what we call centering it. Let me see if I can shift. Try and shift this down. Okay. So let's do that. This is the 4-point moving average, and then this is what we call centered. So it's centered because we want each of these values to be assigned to a specific month, and then that will be easy for us to plot them. So we add 2 of them at a time. So 6 plus 6 divided by 2, this is 6. And then 6 plus 7.5 divided by 2, this is 6.75, and then 7.5 plus 9.25, divide this by 2, we get 8.38, and then these two, 9.25 plus 8, divide this by 2, get 8.63, and then 8 plus 8.75, divide this by 2, get 8.38. And then 8.75 plus 9.75, divide this by 2, you get 9.25. Then 9.75 plus 9, divide this by 2, get 9.38. Then 9 plus 10.5, divide this by 2, get 9.75. So this is what we call the 4-point moving average that is centered. So this one would just be the 4-point moving average. This one is centered. So with an even number point moving average, we would usually ask you to work out the centered value so that if you're plotting them for April, you'll plot 6.75. For May, you'll plot 8.37 instead of these values that just go between those values, between those months. Okay, so the way we calculate it the same. You just need to work out 4 points at a time, but remember to leave a space between so that these values can go there. And then we center them, right? Then that brings us to what we call the method of least squares. Here we have regression analysis method. Okay, so like I said, there are two ways of doing this. The first is sequential coding method, which is what we're going to use. And then there's the zero sum method, which you can read about if you're interested in. But we are going to focus on the sequential coding method. So sequential coding method. Okay, and all that means is we will give you a starting point. That means we tell you where to start counting from. Either you start counting from 0 or you start counting from 1. So we'll tell you sequential coding methods start with x is equal to 0, and then you'll count 0, 1, 2 until however many data points that you have. Okay, so when we see an example, again, it is always much easier than it sounds at first. Okay, so what we're trying to do is we are trying to come up with a trend line equation. This trend line equation whose standard form is y is equal to a plus bx. So a and b, these are constants. So the trend line, just like we said, the trend component, that tells you whether the data is increasing or decreasing. So if we have an equation for the trend line, that will help us to say, extrapolate maybe 5, 10 years from now, what are we likely to get as our data value? Okay, now the A, this is the slope or the gradient. This, sorry, not A, B. B is the slope or the gradient. This is the slope or the gradient. You remember from your line y is equal to mx plus c. So B, this is the slope or the gradient or the rate of change. And A, this is the y-intercept. So when you're given an equation like this, note that this is the y-intercept, the value that doesn't have an x, that is your y-intercept. And then this one here is your gradient. So in mathematics, I'm sure you remember we called it y is equal to mx plus c. So here instead of m, we have b, and instead of c, we have a. Okay, so we want to use the same data points that we used in the previous example when we're working out the 3-point moving average. And the question says, fit a trend line equation to the sales to the sales data, and the coding January is equal to 0. So this coding will always be given. You'll be told the first data point, whether it's January or quarter one, whatever, you must equate it to 0. Okay, so what we do is we come up with a table. So I will put the period here. And let's say this is the data that we were given. We have January, we have February, March, April, May, June, July, August, September, October, November, and December. Okay. Then our sales value. This is what we were given. The sales value, this was 7, 3, 5, 9, 7, 3, 5, 9, 7, 9, 12, 4, 10, 13, and then 9 and 10. Okay, now what we're going to do is we are going to code them. Our time periods, that is what is going to be X. So the time periods will be X, but then instead of January, February, and so on, we are going to call January 0. Okay, so this one will be 0, then 1, 2, 3, 4, and so on. So what I'm going to do is I'm going to have another column with X, and January is 0 because that is what the question says. So this will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So we code them as numbers so that we can add them, subtract, and so on, multiply them. Because if we have January here, we can't add January and February. What does that give us? But if we call January 0 and February 1, then we can add them, for example, or we can multiply them. So we are coding them with numbers so that we can work with them. And then our sales, those are going to be our Y values. So normally, and once you get the hang of it, you will write the X first and then the Y. So I'm just going to repeat my Y values. I'm not changing them in any way. It'll be 7, 3, 5, 9, 7, 9, 12, 4, 10, 13, 9, and 10. So I just wanted the X to appear first. Now we want to come up with this equation. Y is equal to B plus AX, or A plus BX, sorry. Okay, so this is the equation that we want to come up with. So we need to solve for A and we need to solve for B. And the equation for B is given as N multiplied by the sum of the X times the Y values. So we're going to multiply the X and the Y values and add them together. And then we subtract the sum of the X values times the sum of the Y values. This is all divided by N multiplied by the sum of the squares of the X values minus the sum of the X values squared. Okay, and then A, this we work out by saying the sum of the Y values minus B. So this B that we get over here, we're going to substitute it there. And then the sum of the X values over N, like that. Okay, so all of this you can do on your calculator. It's good to know how to work each of these out. Right. So you can see we need the product of the X and Y values. So I'll come up with another column here, and this will be X, Y. So I'm multiplying X and Y. This is 0, 1 times 3, this is 3, 2 times 5, this is 10, 3 times 9 is 27, 4 times 7, 28, 9 times 5 is 45, 6 times 12, 72, 7 times 4, 28, 8 times 10, 80, 9 times 13, 117, 10 times 9, 90, 11 times 10 is 110. Okay, so I also need the squares of my x values. So x squared. So I square all these values. So I have 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared 36, 7 squared 49, 8 squared 64, 9 squared 81, 10 squared 100, 11 squared 121. Okay, that's about everything I will need to substitute over here. Okay, so I also need the sums of all these values, so my totals. Okay, so the total of my x values, so I'm going to say 0 plus 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11. This gives me 66. Okay, and then I do the same thing with the y values. So 7 plus 3 plus 5 plus 9 plus 7 9 here, so I have 9 plus 12. Okay. 7 3 5 9 7 9 12 4 10 13 9 10. Okay, this gives me 98. Okay, so this is 98. And then I add up all these values. So I have 3 plus 10 plus 27 plus 28 plus 45 plus 72 plus 28 plus 80 plus 117 plus 90 plus 110. This gives me 610. And then I also add up these values. So I have 1 plus 4 plus 9 plus 16 plus 25 plus 36 plus 49 plus 64 plus 81 plus 100 plus 121. This gives me 506. So from here, I can see that the sum of the x values, so if I add up all these x's, I get 66. The sum of the y values, this is 98. Then the sum of the products of x and y, this is 610. And then the sum of the x squared. So when I square the x's, I get 506. So my n over here n is equal to 12 because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 data points. So that is my n. Okay, so now I have everything, I substitute. So you see that I need to solve for B first before I can solve for A. So B, this is equal to n. What is my n? 12 times the sum of the product of the x and y. So this is 610 minus the sum of the x's, 66, multiplied by 98. This is divided by 12. So here's the formula. So it's n, which is 12, multiplied by x squared. This is 506, minus the sum of the x values squared. So it's this one, 66, and then you square it. So this, you just type in on your calculator exactly the way it is. 12 times 610. And I have 0.497. Okay, and then we would work out A. Remember the value of B, you needed to work out A, so that's why we work out B first. So A, this is the sum of the Y values, so it's 98 minus B, 0.9497, multiplied by the sum of the X's, which is 66, and then this is divided by N, which is 12. So we have 98. Okay, this gives 5.433. Okay, so now that I have my A and B, my trend line as equation, you know it's Y is equal to B plus AX. So Y is equal to B, 0.497, and A is 5.433x. Okay, so that is our trend line. Okay, and from this, a question that could be a follow-up would be to find the number of sales in January of 2015, or predict what do you think the sales of January 2015 will be. So these were the sales of 2014. So January up until December. And now we want to predict or forecast what the sales for January of 2015 will be. So the question, follow-up question would be the forecast the sales for January 2015. So we would then use our trend line equation. Now, if we were to continue, if you look at our table, we started January 2014, the X value was 0, then 1, then 2, and then all the way up until December. So if we were to continue this table, January of 2015 would have an X value of 12 because it comes right after December. So if December 2014 is 11, then January 2015 is has an X value of 12. So let's say January 2015 we have X is equal to 12. Then we will just substitute this into our formula, and then that will give us an estimate for the sales that we expect in January of 2015. So we have Y is equal to 0.497 plus 5.433, and then we multiply this by 12. So this you would just type in on your calculator 0.497 plus 5.433 times 12, and we get 65.693. So remember, this is in thousands. So in January of 2015, we expect the sales to be 65.6. So I just multiplied by 1,000. Okay, so that is how much we expect the sales to be. Okay, so you can see that this is actually a very good forecasting method. And we can also go in the other direction. Let's say we wanted to see how much did we get, let's say, for December 2013. So December 2013, that means we're going back in time. Let's see. So C. So okay, so it's like we're forecasting, but back in the past, let's say we didn't have the data for 2013, so we can still say, okay, in 2013, that is how much we had. So we do it in the same way. December of 2013, this X value would be -1, because if you look at your table, January of 2014 is 0. So we're going back 1 month. So 0 minus 1 is -1. So our X value is equal to -1. And then we would substitute it in the formula in the same way. So we have Y is equal to 0.497 plus 5, not just 5, it's 5.433. And then we multiply by -1. This is 0.4. This is negative. Yeah, okay, I see what I did wrong over here. I switched my A and B. Sorry about that. Okay, so the formula is A plus BX, not B plus AX. So that makes a big difference. So this is A plus BX. That's what I wrote up here. So it's A plus BX, not B plus AX. Okay, so this, what is my A? This is 5.433, and then my B is 0.497x. Okay, so just be careful with that. Sorry, I think I've been recording too long now. I need a break. Anyway, so here we'd work it out. Let's fix that. So Y is equal to 5.433 plus 0.497 times 12. It's 5.433 plus 497. Okay, so this is 11.397, and this is in thousands of dollars, then this will be 11,397. Okay, and then the same thing with this one here. Okay, because it doesn't make sense to have a negative sales. So we have 5.433 plus 0.497 times -1. And this is 4.936. And then in December. In 2013, we had this is 4,000 in sales. Okay, now you can actually do all of this on your calculator. So the way you would do it, you mode this one. Okay, so you would first have to enter this data. So you go mode stat, to press stat, you press 2, and then you have x plus a plus bx. That is 2 if you're using a calculator like this. So you should be able to enter your x and y values. So the x values you're going to enter are from 0 to 11. So you say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, you've entered them all. And then you do the same thing with the y values. You have 7, 3, 5, 9, 7, 9, 12, 4, 10, 13, 9, and 10. Okay, so you've entered all the values, so you can always check that you have entered them correctly. Then after that, you press on. So you want to work out this sum of x values, shift, stat, then you go to sum 4, and number 2 equals 66. Then you can just write it down. Then again, stat, you go to 4, you want the sum of the y values. There it is, number 4. You press 98. Then again, let's see which one we want. We want the sum of the x times y. So there it is, number 5. This is 610. And then we want the sum of the x squared. So that's 4. Then I want number 1. And this is 506. So you can see that doing it with the table will take you quite a long time, but your calculator does it in a matter of seconds. And then you would substitute them over here. Now your calculator can also work out your A, B, and C. So you just press on and then shift stat, then regression number 7. Then to work out A, you press 1 equals 5.435, and that is exactly what we got, or very close to what we got. It's not exactly because the value I used here is rounded off. So I got 5.435. So this is the exact value if you don't use the rounded off value here. And then for B, shift, let's press on, shift, stat, and then regression to work out my value of B. This is 0.495. 7, which is exactly what I have here. So you can see that you don't need to do all this. Your calculator can do it. You'd maybe just show this is my sum of x squared, sum of y, and so on. And you can use the calculator to check if what you did is in fact correct. Okay, so let's see one more example. Okay, so here it says use the table below for the sales data of the Amanela company and estimate the trend line. So we want to find out y is equal to a plus bx. So y is equal to a plus bx. So we want to solve for a and we want to solve for b. And here we want to then predict the sales value for the fourth quarter of 2011. So with this example, it's not stated explicitly, but in the test you will be told. So say let quarter one for 2007 be 1. So you're going to start your coding at 1. So this will be 1, 2, 3, 4, then go to 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So you would then draw your table as always. So I'm going to do all this on my calculator. And when you draw your table, you should get the same value. Okay, so go to mode. Because I'm entering new values, I have to start again. So I go mode and then stat. Then I'm using two variables and it's a straight line. So it's a plus bx, so 2. Then I enter my values. My x values, I'm starting at 1 to 16. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So those are my x values. Then for my y values, I have 54, 58, 94, 70. Then I have 55, 61, 87, 66. Then I have 49, 55. Sorry, didn't enter that correctly. Just go up. So at number 8, see, so number 7, I have 87. Then number 8, I should have 66. So if I want to correct, I just type 66 now and then equals to. Then number 9 is 49 equal to. So that's how you correct it. And number 10 is 55. 11 is 95. 12 is 74. 13 is 60. 64. 99. And 80. And then you can always go up and down, check. So you 54, 58, 94, 70, 55, 61, 87, 66, 49, 55, 95, 74, 60, 64, 99, 80. And if any of the values is wrong, then you just correct it. Let's say, for example, this 80, I typed in 70, for example. So I just go to it. It's not supposed to be 70, it's 80. I just type in the new value, press enter, and you can see that it will change. Okay, so now that I have my data entered in the calculator, I press on. Okay, and then remember what values I'm looking for. The first one is the sum of x's, sum of the y's, the sum of xy. Okay, so these are the values I'm looking for, which I can get from my calculator. So I go shift, stat, and I go to 4. Sum of my x's is number 2. So this is 113, 136, 136. Then the sum of the y values, shift, stat, number 4. Sum of the y values is 4. So this is 1121. Then the sum of the products, shift, stat, and 4. That's number 5. So this is 9875. Then the sum of the x squared, that's number 1. This is 1496. Okay, so I have everything, and then n is just how many data points do I have. So I have from 1 to 16. This is 16 data points. And then these values, you would substitute them into your formula. Remember, we work out b first. So b, this is n multiplied by the sum of the product of the x and y's, and minus the sum of the x's multiplied by the sum of the y's, divided by n multiplied by the sum of the x's squared, minus the sum of the x's squared. Okay, so we need to work out b first. This is 16. The sum of the xy's, this is 9875. Then the sum of the x's, this is 136, times the sum of the y's, 1121. This is divided by 16. X squared, this is 1496. And then this is 136 squared. Okay, so this you type in on your calculator. Now, when your calculator is in stats mode, the fraction will look a little bit different, but you can just type it in using the division. So we have 16 times 9, sorry, I need brackets here. 16 times 9875 minus 136 times 1121, close the bracket, and then divided by 16 times 1496 minus 136 squared. Close your bracket. So this is 10109. Okay, so this is 1.019. And then the formula for A, this is the sum of the y values minus b times the sum of the x values, and this is all divided by n. So now we just substitute the sum of the y values, 1121, my b here. So try not to round off too early so that your value is exact. So I will add, I'll just write the whole value. So I have 1.019117647, then times the sum of the x values, which is 136, and then this is divided by 16. So on your calculator, we type it in. So brackets 1121 minus 1.019 11.647 times 136 divided by 16, and this is 61.4. Okay, so again, we can check on our calculator if what we did is correct. So I would go to stat and then regression number 7, because this is regression analysis, remember. And if I want the value of A equals, you see it's 61.4, which I worked out over here. And then to get the value of B, shift stat number 7, and I want the value of B, which is 2. B 2, then I get 1.01. So now I write my trend line. So don't make the mistake I did. Y is equal to A plus BX. So Y is equal to A. This is 61.4, and my B is 1.019x. And then the second part of the question says predict the sales value for the fourth quarter of 2011. Now, here we stopped at 2010. So if we were to put the values of 2011, this would be 17, 18, 19, 20. That's the X values. So we're looking for the Y value when X is equal to 20. So quarter 4 of 2011, we have X is equal to 20. So we'll just substitute it in this formula. So Y is equal to 61.4 plus 1.019 times 20. So in your calculator, 61.4 plus 1.019 times, and this is 81.78. Okay, so let's just see. These were the sales values in thousands of dollars. So we can say that in 2011, we expect to have sales of, this we multiply by 1,000, 81,780. Okay, so that's pretty much how you would solve this question, and that's it on this chapter. So you can see it's not that difficult. The calculations are not too tedious either.